We'll move on to part 2, which is slightly more tricky, but is entirely doable. As before, we have made the denominator the same for both fractions. The only difference is that we have a 1 plus c instead of a single 1 on the right hand side. That's why when we multiply out the denominator, we can't immediately cancel out the 1. This is because there's the 1 plus c inside the brackets. Now I've expanded it as before, the purple and blue are the same as you saw on the previous screen, but now I'm going to expand the right hand side fully, getting 8 terms in total. And this is what we get. We get x squared minus ax minus bx plus x squared is equal to x squared plus ab minus bx plus minus ax, as you saw before on the other screen. And now the additions are plus cx plus abc minus acx and minus bcx. Moving everything to the left hand side as we did previously, we get x squared minus cx squared plus acx plus bcx minus ab minus abc, and this is all equal to 0. What I'm going to do now is factorize each of the coefficients of x squared and x and leave the units on the right hand side by themselves. So when we factorize x squared and negative cx squared, we get 1 minus c times x squared. Factorizing acx and bcx, we get c on the outside, a plus b on the inside, all multiplied by x again. And for simplicity, I have factorized minus ab and minus abc, which is quite self-explanatory. Once again, we're going to use a discriminant because we have to show that it only has one real solution. When the quadratic has one real solution, this means that the discriminant must be equal to 0. Therefore, when we input the values into the discriminant, we get this, which looks quite complicated, but when we simplify it, it is only c squared multiplied by a plus b all squared is equal to 4abc squared minus 4ab. You can pause the video and check my expansion if you would like. As you can see in the question, in the bottom equation, it says there's a minus 4ab on the right hand side. That's why we're trying to get everything to look more and more like the equation as we move on. And so I've moved the 4abc squared to the left hand side. All we have to do now is somehow get a multiplier of a minus b squared and divide it to get the equation on the screen. When we take out a factor of c squared, we're left with this. We get a plus b squared in the brackets minus 4ab. And this is still equal to negative 4ab. Moving on now, we're going to try and expand that central bracket. We have a squared plus 2ab plus b squared minus 4ab. But what can this simplify to? It can be simplified to a squared minus 2ab plus b squared. If you didn't know already, this is quite a common expansion of a minus b all squared. Therefore, we can simply say the values inside the brackets are equal to a minus b all squared. And there we have it. We have c squared multiplied by a minus b all squared is equal to negative 4ab. Now dividing by a minus b all squared, we are given what we needed. C squared is equal to negative 4ab all over a minus b squared. Part C is where it gets difficult, and this is the real challenge of this step question. We have to somehow convert the c squared is equal to minus 4ab over a minus b squared into this. C squared is equal to 1 minus a plus b over a minus b all squared. But how do we do this? The answer is in fact on the screen already, but we just need to apply it to this case. The 4ab is crucial again in this question. At the top of the screen, you can see that we have a plus b all squared take away 4ab. And what does this end up being equal to? It's equal to a minus b all squared. And once again, we're going to use this and get 4ab by itself on the right hand side. We can essentially switch around the brackets on the right hand side with the negative 4ab to get this. So in fact, 4ab is equal to a plus b squared minus a minus b squared. And we can simply replace the 4ab with that case on the numerator. Next, I'm going to split apart the fractions. What you can see on the right hand side, the furthest right fraction, is that we have a minus b squared over a minus b squared. But this can be simplified into 1. And that means we have c squared is equal to minus a plus b squared over a minus b squared plus 1. Now if we do some quick rearranging and taking away the square and replacing it over the whole fraction, we get what we require. And there we have it. That's the simple proof to this step question. So thank you for watching this video today. Please leave a like and subscribe, and I'll see you next time.